Today we're going to look at the properties of sinusoidal functions. This could be the title of your topic, or it could be just properties of trigonometric functions, any way or form. This is the simplest way for us to look at trigonometric functions. Obviously, they do become different at some point. In more advanced levels, your trigonometric function will look like a sine bx plus c plus d. So you have an extra variable in there that you'll have to deal with. But in our case, we're only going to look at these three values that will give us the main properties of our function, our trigonometric function. And the same thing applies whether it's sine or cosine. So you should know the basic properties of sine and cosine, the wavelength, the period, the amplitude, and so on. You should know the definitions of amplitude, principal axis, the maximum, minimum, and so on, period, as well. So for each value, I'm going to explain how we can use them to find different properties, and then we're going to go through two examples. So the amplitude can be found through two ways. If you have the maximum and the minimum, which are the y values, so it's always the y values every time I talk about the maximum minimum, then you're going to subtract them and then divide by 2. Or you can take the first coefficient here, the coefficient in front of the sine or cosine, and take the absolute value of it, and that will be the amplitude. For example, if it's 4 in this example, then the amplitude is 4. If it was negative 4, then I only take the positive digit, and I'm going to say that the amplitude is, again, 4. So we ignore the negative. Next, the letter B tells you the period. What it tells you is how many times your function repeats within the 360, assuming you're dealing with degrees here. If it's radians, then you're dealing with 2 pi. So for the period, to know how often your value repeats within the 360, you're going to take 360 divided by the b value, and that's going to give you the period. Sometimes you need to find the b value, so you'll have to look at this at a different way. So we're going to discuss that in another video where we do word problem examples. The last thing is the vertical shift. It means like how you're shifting the function up or down. For example, if the sine curve always starts here, but if I'm going to add a 2 in there, then it's going to shift up by 2. So that's going to be your vertical shift. So this is found by, again, if you have the maximum minimum, you add them, you divide by 2. If you don't, then it's basically just the c value. And this is also called the principal axis. So the principal axis is if you have your curve. The principal axis is basically the curve that just goes through the middle, and it splits the amplitude into half. And it gives you the amplitude, sorry, not splits the amplitude, it gives you the amplitude up and down. So there are three other things that we need to mention, which are the maximum, minimum, and the y-intercepts. Now, sometimes you don't have the maximum, minimum, but you need them. So what you do is you take the principal axis and you add the amplitude. So basically you're here, and then you're just going to add the amplitude, and that's going to give you the maximum value your data could reach. And then minimum is the same thing, but you subtract the amplitude, and that will give you the value here below. Then if you want to graph it, if that's something you need to do, then you are going to you need to know the y-intercept. So the y-intercept is basically just substitute x equals to 0 into your function and see what you get. It's different for sine and cosine, so you just have to be careful about that. So just to do some examples here, we have h of x equals 4 sine 2x minus 3. So the first thing we could find is the amplitude, which is just taking the coefficients and taking the absolute value. So the amplitude is equal to 4 in this case. This is our A, B, and C. It's always useful to actually write them down. A is 4, B is 2, and C is negative 3. The principal axis is useful to find next. The principal axis is always an equation. Be careful. It's always y equals to something. So in this case, y equals to our C value, which is negative 3. Now, having the amplitude and the principal axis, I can find the maximum and minimum as well. So the maximum is going to be me adding these two together. So it's going to be negative 3 plus 4, and that's going to give me 1. and the minimum is going to be me subtracting them. First, you take the principal axis and you take away the amplitudes. Be careful about the signs. That's going to give me -7. So the maximum value my data can reach is, or my graph can reach, is 1, and the lowest value is -7. And then finally, the period. I need to know how often within 360, or at which value in the 360 does it repeat. So the period is just 360 divided by my b value, which is 2, and so it's 180. So at precisely 180, my data is going to repeat. Finally, if I want to graph it, then I could look at the y-intercept, and that's going to be if I substitute in 0. Now, assuming you have your calculator, for sine of 2 times 0 minus 3, this is going to be sine of 0, and sine of 0 is equal to 0. So I'm going to end up with 0 minus 3, which is -3. So my y-intercept is -3. Now, if I need to graph it, I'll try my best to do it here. Basically, it's going to be a sketch. Let's assume you start from 0 to 360. I know my data is going to repeat exactly at 180, so that's when my pattern is going to repeat. So what the B tells you, actually, the period tells you when it repeats, but the B tells you how often within 360 it repeats, not the period. So if the B is equal to 2, it means within the 360 it repeats twice, which obviously will happen at 180. Now the y-intercept, we said we have the lowest value is -7, actually. Let's start with that. The y-intercept will be -3, and that's the principal axis, and our maximum value is 1. So we have all the main properties, and if we're going to graph it, it's going to start at -3, it's going to go up to 1, and then down at a minimum -7, and then it has to go back to this starting point at precisely 180. So I should have stretched my graph a bit more. And then it repeats again, up, down to -7, and then back to this point again at 360. It's a sketch, so it doesn't have to be as accurate. Assuming if you're Math AI, you have your calculator with you. If you're AA, you won't have it for paper 1, but this might be a paper 2 type thing you'll have to do, so it's good to check it using the GDC. And then really quick, just one more example with cosine. Same thing, we are going to first identify all the letters. A is -10, B is 3, and the C is not there, so the C is actually equal to 0. Do pause the video, try this on your own, but I'm going to go through it now. The amplitude is 10, so we're going to take the positive value. So the absolute value, here's what we're going to take. The principal axis, remember it's an equation, so it's y equals to the C value, which is 0. Our maximum is going to be us adding these two, so it's going to be 10. Our minimum is going to be minus, but be careful, it has to be the principal axis, which is 0, minus the amplitude, which is 10. So I'm going to get a -10. Then we have the period, which will be 360 divided by our b value, which is 3. So within 360, it's going to repeat 3 times. And if I'm going to test this, we're going to see this within the graph. So it's going to repeat at precisely 120 degrees. And then we could find the y-intercept. If I substitute in 0, -10 cos of 3 times 0, and cos of 0 is equal to 1, so that's going to give me a -10. So again, on my graph, I will pinpoint the main values. My maximum is 10, my minimum is -10, and this is 360. I have 120 here, and it repeats 3 times within the 360, which means the next time it's going to repeat is going to be at 240. Okay, if I add another 120. And we are just gonna drag this, it starts at -10 as well. So it's gonna go, it's gonna curve up to a maximum. It's gonna come down, and I need to go back to this beginning exactly at 120. So I'm just gonna be here. And again, goes up, comes back down exactly at this, up, and then down. So within the 360, it repeats 3 times. Hopefully this was clear. Once you know all these properties, it's then useful to have data in order to find your A, B, and C. So we're gonna reverse situation where you have the amplitude, you have everything else, and then you need to find your A, B, and C.